Hey, geometry students, it's time for our last test review. So this is test 16A. We're gonna get through this and you guys are gonna rock 16B. So stay put, don't go anywhere. Let's do this.
Flack math! Give me some math and I'll give you some flack. Flack math!
All right, number one, let's get started. A person on top of a 50-meter water tower sees a car below. If the angle of depression between the top of the water tower to the car below is 30 degrees, how far is the person from the car? Okay, so here's our little water tower. We're just gonna go up here, water tower, yay. Ooh, that's a very skinny water tower, very precarious water tower. Okay, so the angle of depression is 30 degrees. So that means this angle here is 30 degrees. So that means this is 60 degrees, okay? So we're trying to find this distance between this dude up here. Let's call him Jim. Jim is his name. Jim's not a funny name, but just the fact that Jim's on top of the water tower, kind of funny. All right, and then here's our car over here. Yeah, I'm gonna draw a car. It's kind of an older Fisher-Price type of toy car. I don't know, I'm gonna stop. Okay, so if that's 60, that means this is 30, this is 50 meters, right? Okay, so let's see, what do we got? What do we have to work with? We have this calculation, we need to find this. So it looks like this 50-meter side is adjacent to this 60-degree angle, and we have to find the hypotenuse. So what trigonometric ratio deals with adjacent sides and hypotenuses? Well, cosine. So cosine of 60 equals 50 over y. But this is a 30-60 right triangle, so how do you find that hypotenuse of a 30-60 right triangle? Well, the hypotenuse is always twice the shorter leg, so this is gonna be 100 meters. But just to be safe, let's just figure this out. So, if this is 100, the cosine of 60 should be 1/2. Is that it? Yep, it is. Number two, in the diagram, circle A is tangent to circle C, which means it just touches circle C in one point there. And BD is tangent to circle A, so that means this only touches circle A there. So that means this is a right triangle. That's a right angle there because the radius to that tangent line is always perpendicular. The radius of circle A is 6, and the radius of circle C is 4. So that means this is 4, so that means this is 4, and then that means this is 6 since this is another radius. So what's that length? 6 plus 4 plus 4 is 14. Okay, so that's 14 between A and D. Find the area of ADB. Okay, so we need to find the area of this triangle. Well, we need the base times the height. So we don't have the height, we don't have this, but we do have two of its sides, 6 and 14. So we're gonna say, we use the Pythagorean theorem, a squared plus b squared equals c squared. So we have our a, let's say that's 6. We need our b, and we have our hypotenuse c, which is 14. Okay, so 36 plus b squared equals 196. B squared equals 160. So b equals the square root of 160. Well, what's the square root of 160? Well, that's the square root of 16 times 10. Well, this 16 can come out and become a 4 times the square root of 10. Okay, so that is our height. So that's our height of that triangle. So how do you figure out the area? Area equals base times height divided by 2. Our base is gonna be 6. Our height is gonna be 4 radical 10. All gonna divide by 2, so I'm just gonna do that real quick just because I can. So that's 12 times the radical 10. which is, let's do that on a calculator. So 10 square root of 10 times 12, 38-ish. So that's about roughly 38 meters, square meters. That was kind of involved. You had to find this height where you had to calculate, okay, so if you had 3 sides, so that was good. It kind of looks like a 30, 60, 90 triangle. Don't be fooled by that. It's not. Otherwise, this would be 12, not 14, right? So you have to find this third side using the Pythagorean theorem. You had to find that because you need the 2 legs to be able to find the area of that triangle. All right, number 3. If triangle ABC has vertices 3, 4, 1, 3, 4, 1, graph the triangle and its rotation 100 degrees clockwise or about the origin. First, we have to graph this. And then this one goes right here. So it looks like what's happening is you're negating both the x coordinate and the y coordinate. All right, so back to here, we didn't really label these, sorry. 3, 4, that's A. 1, 3 is B, and C is 4, 1. So now here's your A prime is right here. Your B prime is right here, and your C prime is right here. Okay, so this is what your new triangle looks like. Cool. All right, number 4. Is the parallelogram shown below a rectangle? Well, it kind of looks like a rectangle. Just because those lines are parallel to each other, it could just be a parallelogram and not a rectangle. So how do you tell if it's a rectangle? Well, you can tell if this is a rectangle if these are right angles. Well, first of all, since these are parallel, we know that the opposite angles have to be true. So let's set these 2 equations equal to each other. We know that's true because we know it's a parallelogram, because a parallelogram is defined by 2 sets of parallel sides, and these arrows tell us that they're parallel. Okay, so 7x plus 6 equals 8x minus 6. Let's solve for x, so get rid of 7x. So then we've got x over here, get rid of 6. So x equals 12. All right, I just subtracted 7x from both sides and ended up with an x over here. Added 6 to both sides, ended up with a 12 there. So if x equals 12, 7 times 12 is 84 plus 6 is 90. So guess what? This is a 90-degree angle. And let's make sure this is a 90-degree angle. 8 times 12 is 96. Minus 6 is 90. Boom. Yes, it's a rectangle. Okay, identify whether the figure below has a line of symmetry. Well, if you can draw a line down the middle and it's the same on both sides, then it does have a line of symmetry. You just drew it, okay? So yes, it does. All right, number 6, identify the type of transformation illustrated below. Well, it looks like, let's see here. It looks like this guy is being rotated all the way around to here. Yep, so see how the A went to A prime, C stays there, so it's rotated about C, point C, and B went all the way to here. Okay, so that makes sense. So yes, it's rotation. And just to be cool, you could say around point C. And technically it could go clockwise too. It could go that way too, but we mostly go counterclockwise just because we're cool and rebellious. All right, number 7. The equation of circle A is x squared plus y squared equals 49. Graph circle A. All right, so what do we know about this circle? Well, remember the equation of a circle is x minus your x coordinate of the center plus squared plus y minus your y coordinate of the center. Well, you're not subtracting anything. So this is really x minus 0 squared plus y minus 0 squared equals radius squared. Well, what's the square root of 49? 7. So your radius is going to be 7 and your center is going to be 0, 0. Your origin. Okay, so if your radius is 7, you're going to go out 7, up 7, left 7, down 7. And then you're going to draw a circle. Wait for it. Okay, that's cool. Boom. Okay, you don't have to be exact. If you want to use a compass and be cool, that'd be awesome. But you get the idea. So just make sure your radius is 7 and your center is 0, 0, and you're good. Okay, number 8, find the measure of angle C. All right, this is a real simple formula. Remember, if that vertex was in the middle, it'd be the average of, if you add the two together and divide by 2, this time you're going to subtract the two arcs together and divide by 2. So all it is, measure of angle C equals 61 minus 15 all divided by 2. Okay? So that just equals 46 divided by 2, which is 23 degrees. And it looks 23-ish, so we're fine with it. All right, number 9, use a calculator to evaluate the expression sine of 57 degrees. Okay, no problem. Just put it in your calculator. Is there a catch? No, 57 sine. Round to the nearest hundredth, so 0.84-ish. That's it. That wasn't very exciting. In the diagram below, find the measure of WXY. So I want to know what this is right here. Given that XY is a tangent, so that just tells it that there's just one vertex here. So this is technically kind of like an inscribed angle, and remember the angle is always half the measure of the arc that it intersects. Well, this is weird. This is like almost, I would say it's a typo. But this 140 degrees is supposed to be from here to here. So this is supposed to be the 140 degrees. So technically, measure of angle WXY should be half of that, which is 70 degrees. So the test does look kind of weird like that. So just ignore that point and just know that this arc goes from here all the way to that point of tangency. I'm sorry, it's confusing. I'll write a letter to John Saxon. Oh wait, he is no longer with us. It's disrespectful. I apologize. Don't tell him I said that. Okay, that's 1 through 10. We're gonna do 11 through 20 in another video, just so it's not too overwhelming for you. We'll probably do that on Thursday. So stay tuned for Thursday's lesson of 11 through 20. Good job on 1 through 10. I'm assuming.
Flack math! Give me some math and I'll give you some flack. Flack math!